Let's talk about cardiac values. So I want to introduce you immediately to an equation. Let me just get rid of something. There we go. Now then, here's my equation for you. I want to introduce you to cardiac output. Don't worry if you don't know what that is just yet. I'm going to stress it to you in a second. Don't worry. Cardiac output, which we're going to have in this vibrant pink. And we're going to put equals. And do you know what's going to come next? I'm going to say that this equals a value called stroke volume. And we are going to multiply that value by something I'm pretty sure you will be familiar with, heart rate. Okay, so we now have our equation. Before we put any values into this and really start analysing this properly, I just want to make sure that you guys are confident and familiar with each of these concepts. So cardiac output, first of all, I want you to be aware of this is a volume of blood, and it is a volume of blood leaving the left ventricle per minute. Okay, so get yourself familiar with that. It's a volume of blood leaving the heart per minute, and we measure it in litres. Okay, stroke volume, however, is a volume of blood, per beat or per contraction, you could say. Now, we could have obviously measured it in litres as well, but we tend to measure it in millilitres because it tends to be, significantly less than a litre. And finally, heart rate is really what we describe as our frequency of contraction of the heart, okay? So our heart frequency, and we measure this in beats per minute. Now, before we go any further, I think it's really important here just to look at logic. Cardiac output is the volume of blood leaving the heart per minute, okay? How would we form that number? Well, we take how much blood leaves the heart per beat or contraction, stroke volume, and we multiply it by the number of beats. That needs to make sense to us. Now, what I'm going to do is I'm going to give you some values. So let's have a look at resting conditions. As I make this, I don't think I'm quite at rest because, I'm working, I'm recording a video. I'm kind of working a touch, probably I'm a bit elevated, but generally let's call it rest. Probably what you guys are doing. We're going to say, and we'll come back to what cardiac output would be, but we know that stroke volume at rest for the average person, let's put it that way, we know that it is in the region of 70 millilitres, okay, 70 millilitres. And we're going to multiply that by the number of beats per minute at rest. And we're going to say that at rest, the average person might be in the region of 70 beats per minute. So what does that make our cardiac output? It makes our cardiac output, let's actually be specific, it would make it 4,900 millilitres, or what we're going to refer to as 4.9 litres. Okay, 4.9 litres. Let me just put a little slash in there. 4,900 millilitres or 4.9 litres, because I've done 70 by 70, it's 4,900, 4.9 litres of blood. So be clear, if we just round that to 5 litres, that is 5 litres of blood leaving the heart per minute at rest, made up of 70 beats, made up of 70 millilitres per beat. Okay, so that's roughly what's happening to you right now. But we're also interested in exercise conditions. Now, this will vary based on the type of exercise and also the physiology of the individual involved. But what I'm going to do, again, we're looking for cardiac output. What we're going to do here is, what do these values increase to? So we find that during heavy exercise, stroke volume can increase to 140 millilitres per contraction. That's doubling from resting condition. Now, that's not an uninteresting thing. You might think, well, it's just an increase. One of the things you might want to reflect on is the heart cannot contract more. During every single heart contraction, the heart contracts fully, entirely. Okay, so you might want to start asking yourself the question then, it's contracting fully at rest and fully at exercise. Well, how does it increase? And I'll get you to sort of reflect on that one a little bit. But we are going to increase this, we're going to multiply this by heart rate per minute, and in the most maximal circumstances for an adult, we might expect that they might be able to get up to something like 200 beats per minute. That would be really heavy anaerobic work, okay, so something very, very intense. So what does that give us as a value? That gives us, feel free to calculate it. Come on, let's calculate it. Why not? I've got my calculator here. Let's clear this. Let's say, okay, we've got 140, that's our millilitres per contraction, and we're multiplying it by 200 beats per minute. What do we get? We get 28,000 millilitres. So if I go back to here, we're getting 28,000 millilitres 28,000, and we're going to obviously compare milliliters, and we're going to convert that to 28 liters. So it's 28 liters of blood leaving your heart per minute during exercise type conditions. So those values are really quite interesting. Now, this one, switching to this one, is the one that you might want to give most thought of how that happens. It's kind of not on this course, but you might want to reflect on that. Would you like me to tell you? I'll give you the briefest of answers. Okay, basically, this value is the value of the blood returning to the heart. So, because there's 70 milliliters of blood returning to the heart during each relaxation phase, that's how much is leaving. So the point is that during exercise, more blood returns to the heart, and again we could get into the reasons for that. So therefore more is ejected, and because more returns, it actually makes the heart swell and fill more, so it stretches, and when it stretches it recoils with more force in like that kind of elastic band mechanism, you know. So that's why that happens. Anyway, I'll leave you with that thought. It's not important for today. Now, the last thing I do want to cover is the final value that I want to describe to you, and that relates to blood pressure. Okay, and you're probably developing an understanding that blood pressure is different at different parts of the cardiovascular circulatory system. But I just want to quickly define blood pressure for you. So blood pressure can be defined as, in fact, let's put it up here. It is, goodness me, James, it is blood pressure. Blood pressure is, and I didn't get any better. It is flow, that is blood flow, so that is effectively cardiac output multiplied by resistance. Okay, resistance. So that's what blood pressure is. Now, the point I would make to you here before we look at some values is if we put our rule in place here and we start thinking, well, let's actually draw out a little kind of a very simplistic kind of blood vessel somehow. I don't like that. Yeah, that red will do. So if I've got some kind of blood vessel here, okay, the point is that we've got blood cells that are traveling up this blood vessel in this direction. And effectively what they're doing is they're exerting a force. Okay, so they're exerting a force outwards on as they move like this. And that is what we describe as the resistance. Okay, now the interesting thing becomes, so let's just write that in. I mean, this is effectively flow, right? And that flow is exerting this force onto the walls. Okay, so that could be kind of that way. Now the point is, if we are unhealthy and we have things like plaque deposits on the walls of our blood vessels like this, I'm just sketching them in, but you can imagine these. You can imagine then that the resistance increases, and that can increase blood pressure when we're not so well. But the point I really want to make to you within this tutorial is the difference between rest and exercise values for blood pressure. Okay, so let's just sort of scroll this down. And I'm going to go over here and I'm going to say, right, let's look at resting values for blood pressure. Well, the first thing to say is we have two types of blood pressure. We have what we describe as systole. This is blood pressure taken when the heart is in its contraction phase, when it's beating. Now, what we tend to find with systole is that blood pressure will be less than 120. Now, I'm not going to get into the units today, but it's mmHg, millimeters of mercury. Okay, I'm not going to get into why that's the value, but the value would be less than 120. Now, that's when the heart is contracting. So we've got this resting value here. You should also be aware of our diastole or our diastolic value. Okay, diastole, this is when the heart is relaxing in the relaxation phase. And we tend to find that healthy people will have a blood pressure of 88 as a value, 88 millimeters of mercury. And again, I'm not going to get into what the unit is and why it's that. Finally, let's look at blood pressure and exercise levels. Okay, exercise levels. When we begin to exercise, this is what we'll find. Our diastolic blood pressure, let's do this one first. Our diastolic blood pressure, or diastole during relaxation phase, will continue to be less than 80 millimeters Hg. Okay, so our diastolic value doesn't really change, but our systolic or our systole value, I think I've chosen a different green, our systole will change from 120 or less than 120. It may go up as high as 180. Why? A little bit like I was saying before, we get this greater ejection from the heart itself, which increases the flow of blood through the circulatory system. Now, we're not taking into account these little resistance points here. They could be a health implication. But during exercise, blood pressure goes up. But this is not dangerous, it's actually a good thing in terms of the delivery of nutrients, okay? And of course it's temporary because it's during exercise. Thanks.